This video is going to show how position time graphs and motion maps are related, how you can make one given the other. Let's just start with a basic example going from a motion map to a position time graph. So we'll draw the motion map. We want to show our evenly spaced hash marks. And let's just make these count by 1 meter each. So we'll start 0 meters, 1, 2, 3, 4, 5 meters. And let's make the object start at 1. So at 0 seconds it's at 1 meter. At 1 second it goes to 3. At 2 seconds it goes to 5. So for these first 2 seconds, the object is moving 2 meters per second. Let's have it stop for 2 seconds and then go to the left. So we have a motion map looking like this, telling us the object moves positive 2 meters per second for 0, 1, 2 seconds, stops for 2 seconds, and then moves at negative 1 meter per second for 2 seconds. Given that motion map, we can very easily make the position time graph because the map literally shows us where the motion is. So let's draw our position time graph. I'll make that a little bit straighter. Try this again. There we go. We've got time in seconds on the x-axis, distance in meters on the y. 3, 4, 5, 6 seconds. And 1, 2, 3, 4, 5 meters. Label my axes. We want to show how much each of these increments are. So we've got 1, 2, 3, 4, 5, 6 seconds. 1, 2, 3, 4, 5 meters. And then we make our graph. So from the motion map, we know 0 seconds, we are at 1 meter. So 0, 1. At 1 second, we are at 3 meters. At 2 seconds, we are at 5 meters. 3 seconds, we're at 5 meters. 4 seconds, we're at 5 meters. 5 seconds, we've moved to 4 meters. And 6 seconds, we move to 3 meters. If I connect my dots, my position time graph would look like this, telling me the exact same thing that the motion map does. A couple things to notice where they are in complete agreement with each other. My longer arrows on the motion map correspond to a larger velocity. Steeper slope on the position time graph means a faster velocity. So steep slope corresponds with these longer arrows. I'm stopped right here, means the object's not moving, the position's not changing. Here on the motion map, stopped, position's not changing. And then we've got a shorter negative velocity over here. The arrows are smaller. Slope is not as steep, indicating a smaller velocity. Now let's go the other way. We'll start with our position time graph and we'll make the motion map. The position time graph here is already drawn. Our time goes in increments of 1 second. Our position I counted by 2 meters. So let's draw the motion map and we're just going to go point by point from the position time graph. It's going to make sense to count by 2 meters as we go across this motion map. Hopefully I made enough hash marks. Let's make this a little bit longer. And we'll label this every 2 meters to agree with the graph. Now we're just going to look at each of the points. At 0 meters, my position is, at 0 seconds, my position is 12 meters. So there's my first dot. At 1 second, my position is 8 meters, but this is also a direction change. So you'll notice that I'm negative and then I'm positive. whenever there's a direction change, the way we want to show that on a motion map is just to jump down. So I'm going to draw my arrow from 12 to 8, but instead of writing the dot right next to the arrow, I'm going to jump underneath. And all this does is show that the position is changing direction without stopping. If I had a dot here and a dot underneath, that would indicate that the object stopped. That did not happen, so we want to get rid of this dot to show that there was no stopping. So back from the motion map. At 1 second, I'm at 8 meters. At 2 seconds, I'm at 10 meters. Whoops. At 3 seconds, I'm at 12 meters. At 4 seconds, I'm at 12 meters. So here I've got the two dots underneath each other. I want to show that there is that pause there. At 5 seconds, I am at 8 meters. And at 6 seconds, I'm at 2 meters. So my motion map would look like this. Agreeing again with the position time graph. We have a negative velocity here that happens to be the same amount here. So between 0 and 1 seconds, I move negative 4 meters. Between, 0, 1, 2, 3, 4, between 4 and 5 seconds, I also move negative 4 meters. So negative 4 meters per second for 2 segments of the motion. Between 1 and 3 seconds, I am moving a positive 2 meters per second. So 2 meters per second down on the motion map. Between 3 and 4 seconds, I stop. My position does not change. That's what these two dots here show. One underneath the other indicates a stop. And then finally, we already looked at between 4 and 5, the negative 4 meters per second. And then we go from 8 meters to 2 meters in 1 second. So this would be negative 6 meters in 1 second. As long as you have one of these two, you can make the other one. Additionally, if you're given words, you can make both graphs.